Are you sure you're seeing me correctly? Let's check for a second. You see this briefcase right here, don't you? This chandelier is probably placed above your head, and that mole you've been trying to pass off as a beauty mark, is it coming from below? So if you're telling me your answers are all correct according to what your eyes saw, sorry pal, you got it all wrong. Not wrong in where or what they were, but how they were placed. The directions you identified are the answers of your brain, but your eyes see them completely inverted, aka upside down. This is the upside down paradox. So does this mean everything on this planet is actually upside down and we see it wrong? You see, you use your eyes every single second of the day. However, unless you're a biology student, scientist, or some kind of Wikipedia nerd, I bet you don't know how your eyes actually work. How do they react to images? This is something absurd to take in, but indeed, your eyes are not what you think. You're not seeing the image as it is. You're not seeing your girlfriend for who she is. And I'm talking literally here, though, for most of you, the metaphorical version would also be true. So does this mean you've been living in the dark until now? Probably. But let's start with the eye. This complex organ is quite literally the camera of the human body, but did you know that it also works like a camera? So eyes have four main members: the cornea, pupil, lens, and the retina. When light enters the eye, it first passes through the cornea and pupil, and is then focused by the lens onto the retina. The retina is where the magic happens. In fact, here's where the upside down phenomenon comes into play. When light goes into your eye, it makes a picture on the back of your eye called the retina. But this picture is actually upside down. So what you see is flipped around. It's fine if you feel like your world is upside down, because it quite literally is in your head. But this is where your trusty old brain comes into play, flipping everything right side up so that you see everything correctly. And I'm so glad it does. Because imagine you wave at someone and you see them standing on their head and waving back at you. That's just gonna be a living life version of The Exorcist every day.
This.
But on the bright side, headstands would get a whole less impressive, so yeah, there is light at the end of the tunnel. Talking about light, this bad boy is actually the reason for all the flippity flips happening inside our head. I'll explain. You remember how I told you that our eyes work like a camera? But let's get even more specific here for a second. Our pupils work like a pinhole camera. A good illustration of the way your eyes take in light and flip the image upside down is a pinhole camera, which is just a box with a small hole on one side and photographic film lying on the other. Light enters a pinhole camera through a tiny hole, and since light travels in straight lines, rays from the top and bottom of the scene cross at the pinhole. This crossing flips the image upside down. You wouldn't have found this phenomenon half as confusing had you just paid attention to your physics teacher in 7th grade, but hey, here we are. Let's proceed to the next step. What happens to the inverted image on the retina that makes us look everything right side up as normal as it is? So basically, the reason you don't see everything upside down in real life is thanks to the body's top scientist, the brain. This is the only reason you don't have to walk around like a bat, although being Batman even in an upside down world would still be pretty darn cool. But anyways, when light falls on the retina, it is transmitted as electrical impulses to the optic nerve and from there to the brain. Essentially, your brain takes the raw, inverted data and turns it into a coherent right-side-up image. In simple words, the upside-down 2D image is processed into a right-side-up 3D image. Come on, I know you're all skeptic people, so if you're in any doubt as to the truth of this, try gently pressing the bottom right side of your eyeball through your bottom eyelid. You should see a black spot appear at the top left of the side of your vision, proving the image has been flipped. Now, please take your hand away from your eye, bro. You look funny enough already. Don't make me watch this as well. Now, it's impossible to make you understand the real process inside the brain with all that upside-down data, and let's be honest, you didn't come here for a full-blown biology class. So long story short, the incoming electrical pulses are separated in the retina. These continue as visual information flows through different parts of the brain where it is analyzed for color, movement, size, and distance. And normally humans have two eyes, so each eye detects light from a slightly different angle and processes both inputs to give us that awesome 3D effect. But this is where things get confusing. Now the question arises, how can a person with one eye still see the world easily? I mean, doesn't the brain require information from both eyes? Well, it's not exactly like that. Sure, the brain needs both eyes, but if I had to describe it in one sentence, I'd say the human brain can be tricked. Yes, people with vision in only one eye often struggle with accurate depth perception. However, in some cases, the brain adapts to whatever it's receiving from eyes, and people with monovision can see with adequate depth perception. Let's look at an experiment for more clear vision, so we gain more clarity on the issue. Professor Theodor Erisman of the University of Innsbruck devised this experiment. performing it upon his student, Ivo Kohler. And man, did Kohler completely trick his brain into doing the unbelievable. The professor made Kohler wear a pair of hand-engineered goggles, and inside those goggles, specially arranged mirrors flipped the light that would reach Kohler's eyes, top becoming bottom and bottom top. At first, Kohler stumbled wildly when trying to grasp an object held out to him, navigate around a chair, or even walk downstairs. In a simple fencing game with sticks, Kohler would raise his stick high when attacked low, and low in response to a high stab. He was basically living the life of Mr. Bean, but by choice. Holding a teacup out to be filled, he would turn the cup upside down the instant he saw the water apparently pouring upward. But over the next week, he found himself adapting, in fits and starts, then more consistently, to such sights. After 10 days, he had grown so accustomed to the invariably upside-down world that, paradoxically and happily, everything seemed to him normal, right side up. Kohler could do everyday activities in public perfectly well, walk along a crowded sidewalk, even ride a bicycle. Passerby on the street did stare at the man, though because, his eyewear looked unfashionable. But who cares? I mean, the experiment tricking the brain did prove successful, right? Erisman and Kohler did further experiments, so did other scientists. Their impression is that most people will be able to make these kinds of adjustments. Images reach the eye in some peculiar fashion, and if that peculiar fashion is consistent, a person's visual system eventually, somehow, adjusts to interpret it, to perceive it, and to see it, as being no different from normal. Oh, I get it. That's why science students believe less in, paranormal activities, because they know how optical illusions may trick our eyes, and so the human brains. I'll tell you in the end how. But right now, I have something important for you to listen to. Which is, seeing right side up isn't something our brains just know from day one. Nope, we don't come out of the womb with that skill. It's believed that for the first few days of life, babies also see the world upside down, as their brains just haven't learned to flip the raw visual data yet. So hey mothers, don't be alarmed if a newborn looks confused when you smile. They're probably just trying to work out which way up your head is. Now, about how optical illusions trick our eyes. To understand how it works on our eyes, consider an ambiguous image, an illusion that can be interpreted in more than one way. When we first look at such an image, our brains might make one assumption about what it shows. Do you guys remember this blue or golden dress? This is a classic example of this. We look at it once and we believe it is something, but if we look again or someone points out a different interpretation, our perception can be changed instantly. I mean, even in a second, the second thought pops up. This is because our brains are constantly trying to make sense of the visual information they receive, sometimes leading to different interpretations. In fact, optical illusions aren't just confined to psychology textbooks or magic shows, they're a part of our everyday life. From the clothes we wear to the movies we watch, it is everywhere. Consider the vertical stripes on a shirt that appears to slim the body, or the horizontal lines that seem to widen it. It's just classic America's next top model shit. So the next time someone you love actually says their world has flipped upside down, just tell them they're not alone. Because it is quite literally.